So let's move into this next section called the greatest common factor. So this is the very first step of factoring. And you may be going, well, what's factoring? Factoring is going the opposite direction of distribution. For instance, you have worked on problems that looked like this. Correct? And this told you to distribute. So that means you're going to multiply. And so you're going to do the 3 times the 2b, which gives you 6b, and then 3 times the negative 5, which gives you a negative 15. Correct? Okay. In this section, we're going in the opposite direction. Okay? Opposite direction. So here's the deal. In this section, I'm going to give you examples that look something like this. This is the answer. And you have to go backwards and figure out what the multiplication problem was that gave you this answer. Are you with me? That's the whole goal of this. This is the answer, just like this one was, and you're trying to go backwards to find the original multiplication problem. Cool? Okay, so let's go back to this distribution problem. You know how to distribute. You distributed the 3 to both of these terms, and this is what you ended up with. If I was to go backwards, right, if I was to check this to make sure we did this right, then I would check this problem over here by doing what operation? Yeah, the opposite operation of multiplication, because I used multiplication to get this answer. So to check the answer, I have to go in the opposite direction of multiplication, which is what? Good, division, which means, how many terms do I have? 2, which means both terms are going to be divided by the same number. Are you with me? Since I multiplied both numbers to get here, I'm going to divide both numbers by the same thing. So what goes into 6 and 15? 3. So I'm going to divide both numbers by 3. With me? And when I do that, this is a 2b and this is a minus 5, isn't it? And the multiplication problem then was 3 times that. Agreed? This is me checking this distribution work. To go backwards from distribution, you're going to have to divide, aren't you? Well, this is my answer, and I'm trying to go backwards, which means you're going to have to do what operation? Yeah, you're going to have to divide. Because we use multiplication to get to this answer. Remember, it's the same as this. This is the answer. We use multiplication to get here, so I've got to use division to go back and find the original multiplication problem. So what can I divide both of these by? Good. Both of them will divide by 6, won't they? Okay, so if I divide both of them by 6, what is left? Yeah, that's a 3k minus 2. Agreed? And what did this have to get multiplied by in order to have gotten this answer? Yeah, it had to get multiplied by the 6 by what you divided out. With me? This is known as the greatest common factor. I am going to divide, because it's the opposite of distribution, I am going to divide both of these terms, or 3 of these terms, or 4 terms, however many terms they give me. I'm going to divide them all by the exact same number, or possibly a variable. So this is my first example. Let me throw another example at you. This was the answer to a multiplication problem, and they're asking us to find the greatest common factor. Well, that means we're going to have to do what? Yes, we're going to have to divide, which means I'm going to have 2 division problems here. You know what? Let's make this problem a little more interesting, shall we? Now how many division problems? Yep, you've got 3. And I have to find something that's going to go into all 3 of these. Because remember, I am trying to find the original distribution problem. When they say greatest common factor, factor means opposite of multiplication. So I'm going to have to divide. Now, what goes into all 3 of these? Yeah, I don't see a number, but I do see an A. So all 3 of these is going to be divided by an A, actually to the power of 1, right? Because there's no higher A. No B's in common. Now, what about that number again? Yeah, some of you are like, there's no number, and I agree with you. However, I am going to let you know that the first term tells you what sign you're going to take out. This first term being negative means you're going to divide all 3 of these by a negative. So let me say it again. Listen up, pause the video, and write this down. The first term tells you if you're dividing out a positive number or a negative number. Okay, I'm back. Did you write that down? The first term tells you if you're dividing out a positive number or a negative number. Cool? Okay, so in this particular instance, we divided everything by a negative A. So what's left? Well, this will be a positive now, won't it? 4b to the second. Agreed? This next one will be negative. Negative what? 6ab cubed. And this last one will be a negative 7. And so the original distribution problem was this trinomial multiplied by negative A. With me? Okay, so I'm going to let you know right now, factoring is all based on you knowing how to find the greatest common factor. It's all based on you knowing how to take this answer and get back to the original distribution problem. That's what this whole thing is based on. Here is the answer to a multiplication problem. What was the original multiplication problem? Here's the answer to a multiplication problem. What was the original multiplication problem? This whole factoring thing is based upon you knowing how to find the greatest common factor. Cool? Okay, so hang in there. I'll be right back. So let's look at problem number 3. They're asking us to factor, okay? And yes, they told us to use the greatest common factor. But here's the deal. I want you just to get used to the directions of factor. And whenever they ask you to factor, the very first thing you're looking for is the greatest common factor. I want you to think of reducing. You're trying to reduce this problem. You're trying to reduce this algebraic expression. You're trying to bring it down to its lowest terms, just like a fraction, okay? So here's the deal. This is the answer. We're trying to go backwards and find the multiplication problem it came from. Remember that. Got it? Okay, so if this came from a multiplication problem, that means you're going to have to use what operation? Yeah, division. So in this case, how many division problems do I have? Good, I've got 2. And the question is, what can I divide both of them by? Well, you're noticing they both have an x, so I shall divide by x. Now here's the deal though. How many x's can I take out of both of them? Remember, I'm trying to reduce this, so I'm trying to take as many x's out of both of them that I can in order to make this as small as possible. So, yeah, I can take 3 x's out of both of them because that's all this one has to give, right? That has the smallest number of x's, which means I'm going to take out an x to the third from both of these. Any numbers? Nope. Am I going to take out a positive x to the third or a negative? Let's see what you remember from the last problem. What is it? Good, it's positive. Why? Because this is a positive. This first term is a positive, which means you're taking out a positive x to the third. Cool? Okay, so What remains? Yeah, you do this division, you're left with an x, minus, you do this division, you're left with a 4. And what did that have to get multiplied by? It had to get multiplied by x to the third. Here is the original multiplication problem that you were given that would give you that that gave you that answer, or the original problem, I should say. Cool? Okay, let's look at this one. Same thing. This was the answer to a multiplication problem. Now we have to go backwards and we have to find out what the original distribution problem was. What was the original multiplication problem? So that means I have to do what operation if I'm going the opposite direction? Good, you're going to have to divide. And twice in this case, right? Okay, cool. So, first, positive or negative? Good, a negative, because the first term is negative, so you're going to divide by a negative. A number? Is there a number that'll divide evenly into both of these? Good, 4. 4 is the largest number that goes into both of those. Now I got two variables. Any a's I can take out of both? Yep, I can take an a out of both. How many a's? Yeah, a to the second, because this one has the smallest number of a's, right? So I can take all of those out at least, can't I? Any b's? Yes, I can take out b's. How many b's? Yep, just b to the first, because this one has the smallest number of b's, right? Okay, so let's find out what's left over after you divide. Over here, good, that'll be a positive 5. Look at the a's. A to the second, look at your b's. B to the second. Good. What sign? Negative. What number? A 4. Look at the a's. Well, they cancel, right? No a's are left. Look at the b's. Yep, the b's cancel. There are no b's left. So here is what was in the parentheses, right? So what was outside the parentheses? That's right, a negative 4a squared b to the power of 1. Good. Does that make sense? Okay, very cool. Remember, factoring is based upon the greatest common factor. Now, let's look at number 5. But before I actually look at problem number 5, I'm going to sidetrack you a second, all right? So my sidetrack I'm going to put down here. You know, in another lecture that I had done on distribution, I gave you a problem that looked something like, let's see. Right? And the way I taught you to distribute was this first term in the first parenthesis, that x, was going to have to get distributed to the 4x minus 3, right? But this plus 1 also had to get distributed to the 4x minus 3, didn't it? That's how I taught you if you looked at one of my previous lectures. Now, the reason I'm bringing that up is this. Does this line look familiar? It looks just like this one, doesn't it? This was the first line on the distribution problem, wasn't it? So here's the deal. What did we distribute? Yeah, the 4x minus 3 got distributed to this x and this 1, didn't it? So if I was going to check it, I'd have to divide by 4x minus 3 because that's what they have in common, right? So up here, you're going to have to divide, right? Here's the first term. Here's your second term because the subtraction separates the two. Just like here, that plus sign separated the two. And what do they have in common? Yeah, the parentheses are in common, right? Those parentheses are in common, aren't they? So, notice, what's left? Yeah, the 4x and the minus 3, correct? That's what's left. And that was distributed into the y plus 2, just like here. There's your 4x minus 3. It got distributed to the x and the plus 1. Here's your y plus 2. It got distributed to the 4x and the minus 3. Are you with me? All of these problems that they ask you to factor came from a distribution problem. And you got to figure out how to undistribute, how to factor. And you know how to do that if you remember how to distribute. You remember how to go backwards. Cool? Okay, so hang in there. I got some more problems. Okay, so let's look at this next problem. Again, this is the answer to a distribution problem. How do I know that? Because the directions are to factor. And so we have to go backwards. We have to find what the original multiplication problem was. With me? Which means you're going to have to do what operation? Divide. Because to go backwards from multiplication, you're going to have to divide. So remember, there are two terms here. How do I know? Because there's this plus sign sitting right in the middle of this multiplication problem and this multiplication problem. And the question is, what do those two terms have in common? Good. They have the z minus 1. They have that parenthesis in common, don't they? Okay, so when I divide out that parenthesis, what remains? Good. I see an 8y from here, and I see a plus 5 from there. So what did this get distributed to? Yeah, it got distributed to the z minus 1. 8y was distributed to the z minus 1. Plus 5 was distributed to the z minus 1. Cool? There's my original multiplication problem. Good? Let's look at number 7. Number 7, same thing, right? I have this minus sign sitting right in the middle of everything, which means I have this term and I have this term. And again, I am dividing because they're asking me to factor, which means I have to find the original multiplication problem. So what do those two terms have in common? Yeah, they have this parenthesis in common, this parenthesis that has a b minus 4 inside. Gotcha. And when I look at that, when I divide, out of the first one, what remains? Good, a 3a. And out of the second one, what remains? Now, here's the deal. I know on that second one, some of you are like, it cancels, there's nothing left. Yeah, that's not true. I have something divided by itself. What's 2 divided by 2? 1. What's 10 divided by 10? 1. What's negative 3 divided by negative 3? 1. What's x divided by x? 1. Right? Anything divided by itself is what? 1. And if you need further proof, isn't there an imaginary 1 sitting in front of that parenthesis even though you don't see it? So, you have a 3a and a minus 1 left, don't you? And what did 3a minus 1 originally get distributed to? Yeah, it originally got distributed to the b minus 4. Cool? Check it out. 3a times b minus 4. Negative 1 times b minus 4. Right? There's the original problem, isn't it? Does this make sense? Cool. Okay, now, check this one out. I'm going to sidetrack you, okay? Just forewarning, I'm going backwards for a second. So, let me give you this multiplication problem. All right, remember, I'm sidetracking you. This is going to help us with the next couple of problems we're going to do, so I'm sidetracking you. Got it? So make sure you write this down as we go, because I'm going to refer back to it. So I'm going to distribute. The a is going to get distributed to the parenthesis of 3x plus y. The plus b is also going to get distributed to the parenthesis of 3x plus y. Correct? And then when I take the a and I distribute it into this parenthesis, we get 3ax plus ay, agreed? Plus 3bx plus by. Agreed? Okay, so here's the deal. In this section, this is what we're going to be given as the original problem. This is the answer. And we have to go backwards to get the original multiplication problem. With me? So I'm going to take this example right here, and I'm going to show you how we're going to go backwards. So we are going to factor. I'm going to put the directions up so you know which direction we're going here. Here is the original problem, and we are going to factor it. Now, the first step of factoring is looking to see if all, in this case, 4 terms, have something in common. Do all 4 of them have the exact same thing in common? No, so I'm not going to worry about that. And now you're like, well, how am I supposed to get from here back to the original? Well, now let's think about it, shall we? This line came from this line, didn't it? Right? This last line came from the second line, didn't it? Which means I'm going to have to take this and I'm going to have to go backwards. With me? So here's the deal. Do you notice these first 2 terms came from here and these last 2 terms came from here, didn't they? So then we are going to pair them up. We are going to do what the authors of the book like to call group them. And I'm going to group them in 2s. Why? Because this second line, giving me this third line, the first 2 terms came from this distribution. The last 2 terms came from this distribution. These 2 terms and these 2 terms came from 2 different distribution problems, which means I am going to group them up. I'm going to take the first 2. Then I'm going to look at the last 2. And by the way, the last 2 start with that sign, that addition sign that was in front of the 3bx. Got it? Okay, so here's the deal. These first 2 terms, I'm going to have to divide. And what do I have to divide by? What do they have in common? Yeah, they have an A in common, don't they? They both have an A in common. And these last 2 terms, what do they have in common? What can I divide both of them by? Good, a B. And the B is what sign? Yes, it's a positive B because the first term is positive, so I know I'm taking out a positive B. Are you with me? Okay, so here's what I'm seeing. On the first 2, I'm noticing that there is a 3x plus y left over, correct? And the original distribution was taking that 3x plus y and multiplying by this a. Correct? Okay. On the last pair, or the second division problem, what remains? Yes, I see a 3x and a plus y left. And what was distributed to this in order to get these 2 terms? Yeah, the plus b. Look, there's the second line. With me? Okay, but you're not done. You're like, why aren't I? Didn't I do a factoring step? You sure did. But remember, you're trying to find the original multiplication problem. That's not a multiplication problem. You see that addition sign sitting right in the middle of everything? That's not a multiplication problem. That's an addition problem, which means I'm not done. I still have to go from this line back to the original. Right? Okay, so now that plus sign separates the first term from the last term. And what do they have in common? Yeah, the parenthesis of 3x plus y. That's what got distributed. So what remains? When I pull this parenthesis out of here, when I divide it out, I get an A. When I divide it out of the second one, I get a plus B. So this A plus B, what did it distribute to? Yeah, it distributed to the 3x plus y. And there is the original multiplication problem. Again, in a previous lecture, you went from here to here and then to here. In this section, we are going backwards. Here is the answer, and I got to go back and find this line, and then go back again and find the original line. This is why it's very good for you to know each step of the distribution process, because it's going to help you go backwards from the answer to the original problem. Cool? Okay, hang in there. Got a couple more of these for us. Okay, so let's look at problem number 8. So they're asking us to factor, which means the very first thing you're going to do is see if you can divide all 4 terms by the exact same number and or variable. Is there a number that you can divide into all 4 terms evenly? Nope. Is there a variable that all 4 of these have in common? No. That 12 doesn't have an x, so you can't divide all 4 of them by an x even. So there's no reducing, because that's what you're actually trying to check for. Got it? Okay, so now remember, I am trying to take this problem, which is really the answer, and I'm trying to find the original distribution problem that came from. So, remember the last problem we did, right? I showed you how we distributed, and then I showed you how we were going to go backwards. Remember, that second line is us taking how many of these terms at a time? 2. Because remember, the problem I did over here, remember, these 2 terms came from this parenthesis and a distribution, and these 2 terms came from a parenthesis with a distribution. So to go backwards, I've got to take 2 terms at a time. So I'm taking the first 2 and then the last 2. And I'm going to divide, right? Because if I'm going backwards, I have to divide. So what can you divide both of these 2 by? Yes, an x. An x to what power? Good, the second power, because that has 2 x's. That one's got more, but that one only has 2 to give, right? It's the smallest amount, so I'm taking x squared out. In the second pair, good, the 4 can be divided, but it's a positive 4 because you notice the sign in front of that 4. You have to remember it. Good? Okay, so let's look. When you divide both of these by an x squared, let's see what remains. Here, good, you get an x. And a positive 3x squared divided by x squared? Yep, that's a positive 3. So what got multiplied to this x plus 3 to get these 2 terms? Yep, that x squared. There was the original distribution problem that gave me the first 2 terms. Got it? Okay, let's move on over here. When I divide, what remains? Good, an x. And positive 3. Excellent. So now my question is, what got distributed to the x plus 3 in order to have gotten these 2 terms? Yes, this plus 4. Is this making sense? Okay, but are we done? Good, you're not done. Why? Because it's not a multiplication problem. It's supposed to end in a multiplication problem. With me? So, that plus sign separates the first term from the second term, doesn't it? And what do those 2 terms have in common? Yeah, they have the parenthesis in common, don't they? The parenthesis is exactly the same. Both parentheses have an x plus 3 in there, don't they? So, what remains? Yeah, you do this first division, you're left with an x squared. You do the second division, you're left with a plus 4. And so this x squared plus 4 got distributed to the x plus 3. Notice, do your check. X squared times the x plus 3, right? Positive 4 times the x plus 3, right? Again, go backwards. You do this distribution, you get the first 2. You do this distribution, you get the second 2. There's your original distribution problem. Cool? Excellent. Okay, so let's look at this 9th problem. Again, you're trying to reduce this. Is there anything in common with all 4 of them? Nope, then I'm not going to worry about it. How many do you take at a time? Yes, 2 at a time, because you're trying to go backwards. You're trying to find this middle step. Remember that. Okay, so I am going to pair them up. There's the first 2, correct? And the second 2, right? That 10y is a negative 10y, so you have to put the negative with it. Good? All right, on the first pair, what can I divide by? Good, I heard you say 6. Anything else? Good, and they both have an x. Excellent. The second pair, what do you divide by? Some of you are like a 5. Yep, you see that right away. Anything else? Excellent. And some of you said that 5 is negative because that first term is negative. Excellent. Good job, you guys. All right. So you do this division here. Tell me what remains. Good. A 2y minus 3. And that got distributed with the 6x. Good, right? Excellent. How about over here? What remains? Good. That's a positive 2 because you're dividing 2 negatives. A positive 2y. And this positive 15 divided by this negative 5. Good. That's a negative 3. And what got distributed to this? Yeah, the minus 5. That's how they got the last 2, right? Okay. Are you done? Nope, because there's a minus sign in between all of this. Separating the first term and the last term, right? What do they have in common? Good. They have a 2y minus 3 in common. They have that parenthesis. And gratefully, the parenthesis is exactly the same. If it wasn't, we're going to be in a little bit of trouble. But gratefully, it's exactly the same. So, tell me what's left. Yep, out of here we have a 6x. And out of here, that minus 5. And this got distributed to the parenthesis 2y minus 3. Cool? Getting the hang of it? I hope so, because in the next lecture, we're going to use this process and one additional step. So, have fun with this stuff, and I'll catch you on the flip side.